Hi, welcome to this introduction to a GUI-based approach to machine learning for sports betting. I'm going to be looking at horse racing today. Let's get started. First thing I need to do is open a data file. I've got 2015 to 2017 flat handicap data here that I'm going to look at. Let's first of all take a look at the various windows on the screen. Up here we've got a window that shows the data file that I've just loaded up, how many rows there are, and how many columns of data. Down here we've got a snapshot of the first few rows of data. Over here we've got a clear button which will clear the checkboxes on the window below. We've also got a drop-down menu for selecting the model we want to implement: k-nearest neighbor, random forest, gradients boosting, or neural nets. There'll be others in the future, but I'm going to stick with random forest. We also have to define what the event ID is that we are working with here. The event ID is anything that depicts a particular event in the data. In this case it's a race. So obviously it's guessed correctly here that the race ID is the event ID. We can see that a race ID depicts a particular race. We have to define what the win-lose field is, what depicts whether a horse has won or lost. In this case it's FinPOS. We could change that if we wanted to, if it was called something different. And then finally we have to define the price of the price field for each horse, and that's in this case BFSP. The field called BFSP is Betfair SP. We need to probably take a look at our data and get a feel for it. If we put the cursor over any of the input fields, we get a frequency chart on the right popping up. And we can look at different fields and see what the spread is. We can also go up here where it will update this window and tell us what feature we're currently looking at, how many instances there are, how many occurrences there are, how many rows in other words, how much missing data there is, in this case none, what the mean value and max and minimum values are. Okay, let's go ahead. One other thing is, you'll notice here that some of these checkboxes don't appear next to various rows. That's because in machine learning you can't throw non-numeric data at the machine learning algorithm. So going, which is not numeric, is not enabled for input into the algorithm. But if we wanted to use going, we could check this one hot box here on the right, click one hot in code, and it will convert it into a numeric form so we can use it in our model. I'm not going to do that on this video, but probably on a subsequent one. Okay, I'm now ready to clear the checkboxes and select some items to place into a model. This is just an example run through, so I'm going to go with let's go with race distance, days since last run, previous days since last run, how many races the horse has run, and trainer strike rate. Okay, I'm ready now to create a model, so I click create. The next subframe will come up in about 7 seconds because it's just loading up the random forest algorithm. So we should get a new frame coming up in a second. Okay, here we go. Now we've got a final check on the features we've selected, make sure that they're all correct. It tells us here that we're using a random forest model, and the baseline, if we backed every horse in every race, we'd have lost just over 3%, and the variable return would have been just over 1.5%. We could click on hyperparameters here, which would find the optimum hyperparameter tuning for this particular model. I'm not going to do that here. I'm going to accept the default hyperparameters when I create the model here, because the hyperparameter tuning on this particular dataset will take about half an hour. But it's useful to do when you've settled down on your model, because it will give you a snapshot of results with the hyperparameter tuned parameters, and it'll be alongside the results for the default parameters so you can compare them. So I'm just going to create a model with the default parameters. This will take about 15 seconds to run. on this particular data set, it's actually partitioning the data into fifths, and it's training the data on 4/5 of the data and then testing it on the final unseen fifth. It does that 5 times, rotating the data to get a more general impression of how the model would perform on unseen data. Okay, we've got the results through here. According to the probabilities that the model produces, the top ranked horse would have produced 12,100 bets, impact value of 1.29, actually made a profit, return on investment here, and the variable profit if we back variable stakes and the variable return. You then get the results for the second rank, third rank, fourth rank, and so on down to the 10th ranked horse. Down here it shows the feature importance. This is what the algorithm decided was the relative importance of the different features that we put into the model. It's clearly saying that the trainer strike rate had the greatest influence on finding winners, and the least important was the race distance. I could now click Save Results, and that would output all of the bets on every horse in every ranking out to a CSV file, so we could perhaps analyze that a bit further with the probabilities it produced. I'm not going to do that now. I'm going to actually go back to this menu here, where I could, if I wanted to, save the model if I was happy with it or wanted to work with it later. But what I'm also going to do, you could load today's declarations. So it loads up the data for today's runners. There are 80 runners running today. And then if I click Model Decks, it will run the model I just created against today's declarations and save the output to a CSV file where you can then check who's ranked first, second, third, and with what probabilities. So if I click Model, it's done that. It's run the model against today's declarations and outputted it to today's rats.csv. Okay, that's it for now. I'll probably make another video later to show you the one-hot encoding and hyperparameter tuning. If you have any comments, suggestions, constructive criticism, please use the comments section below. Thank you.